Hello and welcome to another video in this amazing series on Python tricks. And in this video, we are going to learn about the concept of mutability versus immutability. So basically, whenever you are dealing with objects in Python, then you should be knowing these two concepts because the objects in Python are broadly classified as mutable object or immutable object. So if you don't know the differences between these two concepts, then you may run into issues that would be unexpected for you. So it's really important for us to understand the difference between mutable objects and immutable objects. So let's get started. So before we begin, let's take a look at what are mutable and immutable objects based on their definition. So all those objects whose value can change after they are created. So basically, if you have created an object and you are able to change its value or the content inside that object after it was created, then it is called as a mutable object. Whereas an object whose value cannot change after it was created is said to be immutable object. Or in other words, if an object is created and you are not able to change its value or the content inside that object, then it is called as immutable. Now we are going to see examples around mutable and immutable objects, and we are going to understand about them more. Now from the screen you can see that integer, string, tuple, boolean, float, all these are immutable objects, whereas lists, sets and dictionaries are mutable objects. So let's try to create these objects and see how they differ in terms of working. So we are going to see working of immutable versus mutable objects. So now let's take an example of a string. Basically, we are going to create an object which is of type string, and it's an immutable type, of course. So we are going to see how immutable types work. So let's say that I have created a string which contains a string, basically a string object which contains the string hello. Right? I have created this string object. So behind the scenes, what Python is going to do is that Python is going to create an object and contain this string in that object hello. And this variable a will start pointing to that object. Now, I want to change the content inside or the value of this object. So what is the value? Value is hello. And I want to change this value. How I can do that? Let's say that I want to change the value at position 1. Basically, you can also index this string, right? So this is the H is the character which is located at index 0, E is located at 1, first L is located at 2, then another L is located at 3, and then O is located at 4. So if you try to access A of 0, this should give you the character H. Now let's say that I want to change the character which is located at position or index 1, and I want to change it to, let's say, X. Now this is the statement where we are actually trying to modify the content of this object. Pay attention that I am trying to modify the content inside this object after it was created. And here is the statement. Here is where I am trying to modify its content. And at this point, Python is going to report an error, and it is going to say that string object doesn't support type assignment. So we are going to see that example through code as well, but for now I'm just trying to explain you what's happening. So at this point it is going to report an error, but at this point let me clear out some space. Let's try to understand what will happen when we try to replace this entire hello string altogether. So let's say I want to replace it with world, string world. So will this result in error or not? I just want you to think about this. Will this result in error? Earlier we just tried to replace one single character in that string, and we know that it is going to result into an error. But what will happen at this point, at this statement? Will this also result into error? Let me tell you how assignment works in Python. If you are trying to assign a complete string object or any object to a variable, note that we are not indexing. We are not trying to index here anything. So basically what does this mean is that we are essentially trying to replace variable a with some other object. It can be string or anything. So what Python is going to do, Python is going to create another object, string object, and it is going to store the string world and will make this variable a point to that object. So this is again another immutable object. Now this means there won't be any error, which means this is a perfectly valid statement. You can write this. Earlier when we were trying to, after we created this, let's say we were trying to store x here, and this is where we will see the error, because this means that we are trying to change or modify the value at the index 1. But when you do this, this means that Python is going to create another object, store that particular string, it can be integer or any string, and that particular object will be pointed by this variable. Basically this variable is actually going to point that new object. Now what will happen, this link, this will be gone, this will be unlinked, and because now this particular object is not being referenced in your code, so Python's garbage collection will kick in and it will clean up this particular object from the memory, because now that particular variable is pointing to some other object. So I wanted you to understand this part. So I'm going to repeat it once again. So listen carefully. So what happened when we created this string object, and immediately if we try to write array of 1 or any index in that existing string, and we want to replace it with some different character, then we are telling Python that in this string object, replace, for example, here we said that at index 1, replace that character with the new character x. So basically we wanted Python to create something like this. But this is not possible, because this is where we are actually trying to modify the content of immutable object. This string object is immutable and we are trying to modify its content. What we wanted initially, it was HELLO, but what we are trying to do is that we want to convert this E to X, and that's where we are trying to modify its content, and that's where the error will come in. If you try to do this, Python is going to throw an error. But if you try to assign a different object altogether to that variable a, like here we are doing, so this variable a will be assigned with a new object. This is perfectly valid, because in that case we want Python to create another object and make that variable point to that new object. So that's what the difference is. Let me take another example of tuple, which works similarly as strings, because it's also of type immutable. Now in case of tuple, let's say I create a new tuple t, which is containing items 1, 2, 3. Now in case of tuple also, you can index and actually access the individual items contained in that tuple. So let's say that I want to access the first element, then I can do this t of 0. And if I want to access this item at second location, I can do t of 1, or item at first index. Now anyways, what I want to tell you is that if you try to do t of 0 equals 100, what does this mean? This means that I'm trying to modify the value of the first index, right? So this is, as you might have guessed, this is going to give you error. So it will say that tuple doesn't support item assignment, and which is true. In case of a string also, you will get the error something like this, that a string object doesn't support item assignment, and you are going to see the same thing here as well. However, similar to the string, if you try to create altogether a new object, which is something else, let's say 100, then 200, then 300, this is perfectly fine. In this case, Python is going to create a new object. Here Python might have created an object which would have contained that tuple 1, 2, 3, and t would be pointing to that. But when you did this, you're not saying that, you're not instructing Python to modify this object which was immutable. Rather, what Python does after this is Python is going to create a new object, and it's going to store 100, 200, and then 300. This is again, this object will be immutable tuple, and then t will point to this. Now this will be unlinked, and this is going to be cleaned from the memory. So this is similar, like how a string worked, and similarly here how tuple works. They both are similar because they both are immutable. So now let's get to the mutable objects and see how they work and how they are different. Now let's see the example of lists, which is mutable type. Now let's say that I want to create a list which contains items 1, 2, 3. So in case of mutable, this was the parenthesis. In this case, it's a square bracket, right? Now at this point, if I want to change the value present at the 0th index with 100, now as you might have guessed, this works. This is completely fine, because what will happen is that Python will be allowing to modify this value, and after this, if you try to refer a, then a's value will be 100, 2, 3. We have changed the value present at the first index. So let us also try to understand what will happen behind the scenes while we are creating the list and performing any kind of mutations, or while we are changing its value behind the scenes. Let's see what is done by Python. So let me clear up some space. And so at this point, let's say once we have created the list, Python is going to allocate an object, and it is going to keep 1, 2, 3 in that object, right? And a will be pointing to that object. Let me remove this. So once we have done this, this is what Python will do behind the scenes. Now after this step is executed, a of 0 equals 100, which means at this particular index we need to modify this value and store 100. So in the same object, 100 will be replaced at the 0th index. In the same object, there won't be any separate object created, and there won't be any modification, or there won't be any separate object involved in this. In the same object, it's in place, right? Because it's mutable object, so the same object will be changed. So we have modified value of the same object, right? At this point, once we have done this, I mean, let's say that we want to also perform append operations. So list also has different operations that you can call, and you can modify value in different ways. For example, you can call append a dot append. So what this does is that it adds an integer, basically whatever object you pass it. Let's say we are adding integer, so it will append an integer to the end of the list, right? So let's say we want to append, let's say 50. Now at this point, in the same list, Python is going to add 50, and list will be updated in this way. So after this step, list will look something like this: 100, 2, 3, and 50. But there won't be any separate object. After each step, you can check the memory address or the ID of the object, and you will find that it is the same object that is getting updated. And let's say that you can also perform pop. So you can perform pop operation, and from the same object, 50 will be removed. So pop operation basically removes the item at the end of the list. And you can also perform insert. And insert, but for insert you need to pass an index. For example, let's say I pass index 1 and I want to store 20. So the same list will be updated, and it will be something like this: 100, 20, 1, and 3. So I guess so at the index 1 we have stored 20, and the rest of the list after that remains same, and list before that remains same, just that at index 1 we have added an item 20. Another thing that I would like to tell you at this point is, let's say that once we have created the list, I'll rub this. Let's say once we have created the list, we are assigning it to a different variable, b equals a. So as I have already told you that the object that will be created here, which will be 1, 2, and 3, initially a will be pointing to it, and after we do this, then b will also start pointing to the same object, right? Now after this point, using b or using a, if you try to modify the values of the value of that particular list, then it will be reflected for both the variables. So I'll tell you what do I mean by that. because A and B are pointing to the same list object. So let's say that if I do A of 0 equals 100, as I was doing previously, then as I've told you, right? So this the same list object will be updated. So here 100 will come. Now if you try to access B, if you try to read, basically if you try to do something like print B, then in B also you will see that 100 appears. The change is reflected in B as well when you try to access the list using B. So 100, 2 and 3, you will be able to see that. Or let's say that if you want to change list using B, so let's say you did a B dot append and you append, let's say 50, right? So here 50 will come. Now if you try to do something like print A, then at this point also you will see that change that you made using B will be reflected. So 100, 2, 3 and 50. So because it's a mutable list, it's a mutable object, you should be able to mutate it using any of these two variables. Now let's quickly run down through all the examples that we have seen like in the past. So let's start with the string, so which was an immutable type that we have seen. So let's say we created a string called hello. Now let's try, because now the string is an immutable object, so let's try to mutate, or let's try to change its value the way we were doing it earlier in this video. So let's say that I want to update the first index with, so first index is the letter the character E. Let's try to replace it with X, and boom, we get the error. So the error says that it's a type error and str object does not support item assignment, which is pretty clear that you're not allowed to mutate or change its value. However, on the other hand, if you try to assign altogether a completely different string object to the variable A, then it should work. So let's say that however, before doing that, let's try to check the ID of A, which is the memory address of A. So I take that ID function, pass object A to it, and you see that the ID is something like this. It ends in 816. But now let's try to have this thing. So I'm now taking the string word and assigning it to A. And now let's see what is done here. However, there is no error. Now let's check the ID of A again. Now you see that the memory address has changed. Now it ends in 288. Earlier it was 816, which tells us that Python, once you tried to assign a new string object, Python is going to create entirely new string object and make that variable A point to the new object. And earlier, the object that we created, that is going to wiped up or cleaned up from the memory because of the Python's garbage collector. So one more example on string. Let's see that. Let's say that I have again, same thing, hello. Now, one thing that I want to do here is that I want to assign B to A. So I want to assign A to B. Basically, B will be assigned with A. Now, after this, if you check the ID of both B and A, you will see that the ID of both B and A are same, which means now B and A are pointing to the same string object. But however, let's say at this point, you want to replace one character in A, right? Let's try to do that. Earlier, we have just tried it directly with the assignment operation, but there is a replace method for every string object. Let's try to use that and see what happens. So let's say that I do A equals A dot replace. Let's say I want to replace E with X, right? And now you see that this worked. But now have a look at this. What am I doing is that A dot replace is supposed to return a string object, and that string object will be assigned to A. And let's see what is the ID of that string object. Now, before that, let's see what is A. You can see that now E is replaced with X. And now if you do ID of A, you will see that the ID is ending in 288. But if you see the ID of B, it ends in 544, which means B was pointing to the older string object, which was hello. Now A has been assigned with a new string object, which is hxllo, whatever you can call it. Now this means that if you just check B, it is assigned with hello, and A has been changed, which means if you attempt to modify the content of an immutable type, Python is going to give you a separate object. And when they were pointing to the same object, at that time, if you are only trying to read the value of that object using either B or A, it's fine. But if you try to modify the content, Python is going to create a new string object or new immutable object, and it is going to create it for you. Let's quickly see the example of tuples as well, which is again another immutable type. So let me try to create a tuple. Let's say this tuple has 1, 2, and 3. Now, if you try to assign at the first index, let's say I am trying to assign 100 at this point, because it's an immutable type, you cannot modify its content, and that's where I get this error which tells that tuple object doesn't support item assignment. There is one more thing. There's a small caveat with tuple, that essentially tuple groups different objects together, right? It's a sequence, and in that sequence you can also keep the mutable types. What I'm trying to say is that let's say that you want to have a tuple, but you want to keep a list in that tuple. For example, this list is 100, 200, and 300, and then let's say 52. So this is a tuple which contains one integer object, which is immutable, but it also contains as the first item of this tuple is a list, and list in itself is a mutable type, right? Now, if I try to assign at 0th index, let's say, because it's a mutable type, let's say I try to assign it some other value or some other list. Let's say I try to assign it an empty list. Of course, it's going to give me an error that you cannot assign any of at in if you pick any position, if you pick any index, and if you try to change its value, you are going to get this error. If you try to change its value directly through assignment, through equals. But what I can do is, if I try to access that index, which is located at a of 0, I can do one thing. A of 0 dot append, let's say I want to append 400. I can do that. And if you see that the content has been modified. So what we were saying till now is that tuple is an immutable type and we cannot modify its content, but you can see here that its content was modified. But this is a small caveat. This only happens when you try to store an immutable, if you try to store a mutable type in the tuple, which in itself is an immutable type. So you have to be careful when you're trying to store a mutable type in a tuple. Tuple is immutable, and if you store a mutable type like list or dict, then you need to be careful. Now let's finally see an example of a list which is a mutable type, and we will see how it works. So let's say that now A is assigned with a mutable type, which is 100, 200, and 300. Now let's quickly see the ID of A. It ends in 784. Now let's try to modify its content. I want to do A of 0. Let's say A of 0, I want to assign it with, let's say, 400. And now if I see, then that particular value was changed. I was able to assign it. So that's where the mutability comes into the play, right? I was able to modify its content. I was able to change its content. Earlier, I was not able to do that because tuple, I was trying to do it with tuple, I was trying to do it with string. They were immutable type and item assignment was not supported there. Another thing that I would like to do here is that, let's say I do B equals A. Now, if you check ID of A, it will be equal to ID of B. You see that it's true. So let's see ID of B explicitly. It ends in 784, 14784. You can see that it's the same ID that I have printed here, which means A and B are now pointing to the same list, which is a mutable type. Now, let's say that, just see what it prints. So B, the content of B is also 400, 200, 300, and content of A is also 400, 200, 300. Now let's say that I want to do B dot append, and I want to append 500. Now let's try to see what is the content of A. You can see that it was reflected in A as well. A now has got 500 as its last item. So append, what append does is that it appends the last, whatever item you're passing to append, it will attach it to the end of the list. So that's what it did here. So 500 was attached here, and you can see that A and B both have that new content, right? If you'll see that ID of A, it's still the same, it's 14784, and then ID of B is still 14784, which means they are still pointing to the same object. So what I'm trying to convey is that in case of a mutable type, if there are two variables that are pointing to the same object, if you modify the content of that object using one of the variables and you try to access the same object using another variable, then you will see those changes reflected in that particular object, which is what we have seen here. I modified its content by adding 500, and for adding 500 I used the variable B, and when I printed A, I was able to see that 500, because of course they both are pointing to the same object. And I would like to encourage you to try out more such examples and try out things around mutable and immutable objects and play with it to understand and gain more hands-on on it. It's not it's an easy concept to know, but sometimes it confuses a lot of people. Like if you're working on a very large code base, you may find, even though mutable versus immutable is a very like easy concept to learn, it may trick you. And yeah, that's why it's really important for us to know about it. It's a very core concept, and it is really ubiquitous. It's present everywhere. Every time we are going to deal with an object, we are really dealing with either a mutable object or an immutable object. So with that, I would like to end this video, and I hope that you liked the video. And if you liked it, please hit a like, share, and subscribe to my YouTube channel. And also, if you think that there was difficulty in understanding something, then put that question in the comments, and I'm going to try my best to help you out. Until then, bye.